Today, this is for class 12 physics. I am going to deal with semiconductors. There's an important part here that you must remember as well as you must know about it. There are two types of semiconductors. One is extrinsic semiconductors and another is intrinsic semiconductors. But I am going to deal with intrinsic semiconductors because it is of two types, that is P type and N type. So here intrinsic semiconductor, here doping is done either by a pentavalent or by a trivalent. And this semiconductors we take as a silicon chip or the germanium chips. So here uh, about your, I'm going to start with this. And as you have already learned, you know that there are two types of band, valency band and conduction band. And for some semiconductors, the energy gap is less than 3 electron volt. That all the basic you have learned earlier. But now there are two types of doping. One is the pentavalent doping, other is the trivalent doping. So in pentavalent doping, we take valency 5. So what happens here? Either you take a silicon chip or a germanium chip. In the silicon chip, it has a 4 valency, so it forms a covalent bond with the other silicon atoms. Now, if it is doped by pentavalent, then 4 of its electron will form covalent bond with the nearby silicon atom, and one electron will remain there, and this will remain there. So this electron helps in the conduction of current. So this is also called as conduction current. This electron, it helps in the conduction. So here, what is the most important thing here? The thing is that when a p type, that is n type, this is n type. Here, when n type means in n type, the number of electron is more, majority charge carrier is the electron. So in n type, when it is dropped by a pentavalent atom, what happens during this process? Some of the bonds, covalent bonds, breaks up and the electrons are released. But when the n type semiconductor is formed, the electrons, they returns to their respective holes, but that means they returns to the hole. In this process, some of the holes remains there. That means you can think in this way. That means doping, while doping, the process is not given here. That means in doping, you must require some mechanism, some heat treatment like that, so that the silicon atom is replaced by a pentavalent atom. During this treatment, some of the covalent bonds breaks up and electrons are released. But when this n-type semiconductor is formed, at that time, the electrons, it returns to its hole. In this process, what happens? Some of the holes remains there. So in n-type semiconductors, your majority charge carrier are the electron and your minority charge carrier is your hole. At the same time, one thing happens here. Due to this doping, this because of this pentavalent, an energy band is created just below the conduction band. So because of this doping, and there is an energy band just below the conduction band, and because of it, the electrons can easily move from the from that band to the conduction band, and the conduction of electron is possible. Now we go for the p-type semiconductors. In p-type semiconductors, here trivalent atom doping is done by a trivalent atom. So three of its atom forms covalent bond with the nearest silicon atom, but one remains empty, that is the hole. Now here what happens, that the nearest bond it breaks, maybe that a nearest bond breaks and that electrons moves to the hole, and again a new hole is created. So here there is a movement of the hole. So in this semiconductor, when doping is done, and again here an energy band is created because of this trivalent, an energy band is just above the valence band, and so electrons can move to that band, and holes moves down into the semiconductor in the valence band, so more holes are created. So again in this process, what happens in this process, in the process of formation of this p-type semiconductor, some of the bonds it breaks and the holes are created. But when finally this p-type semiconductor is formed, then so all the electrons that it can't return to the holes, some of the holes remains there, as well as some of the electrons it remains there. But originally in the trivalent doping, holes are originally present there, and again some holes are created. So in this type of p-type semiconductor, the majority charge carriers are the holes, and the minority charge carriers are the electrons. So in this way, the p-type and n-type semiconductors are formed. And in the p-type semiconductors, the movement, that is the movement of the hole in the valency bands takes place. So in this way, the flow of the current takes place. Now we move to the formation of p-n junction. So in p-n junction, these p-type semiconductors and n-type semiconductors, uh, both are now together, they form a p-n junction, and this p-n junction it is called as a diode. Now here what happens, that during the formation of p-type and n-type, the p-n junction, during the formation of p-n junction, an energy barrier in between them is created. How this energy barrier is created? What happens, that due to the concentration difference, that is there is surplus electrons in the n type and there is surplus holes in the p type. Due to the difference in the concentration, the electrons moves from the from n type to the p types, and the hole moves from the p type to the n type. That means diffusion takes place. So here, due to the concentration difference, what happens when the electrons move from the n type to the p type, that means the space, as the electrons move, that means that space it becomes deficiency of electrons, so it becomes positively charged. And similarly, when holes moves, that means there is deficiency of positive, that means a negative charge is developed. So at the junction, we get yeah, on the n side we get this positive charges, and on the p side we get the uh, negative charges, so that there a barrier is formed. So a barrier is formed, and this is called as the depletion layer. So here again, two types of currents are flowing. Due to concentration difference, the electron from the n type it moves to the p type, and the hole from the p type it moves to the n type. At the same time, a field is created in the depletion layer, and that is an electric field is created, and because of this electric field, the from the positive charge, that is from the positive charge uh, movement to the negative charge, and from the negative charge to the positive charge takes place. Means if you can say it is better to say that in the depletion region the electric field is produced, and because of this electric field the mm, from the positive side the flow is towards the negative side. So here two types of currents are there. One is the current because of the majority charge carrier, that is the concentration difference, that is from the n type electron moves to the p type and the whole p type moves to the n type. This is called as diffusion current, and because of this electric field produced at the depletion layer, the flow of the current is called the drift current, and the direction of the drift current is opposite to that of the diffusion current. Now, when this diffusion current becomes equal to the drift current, your PN junction is formed. That means finally, when the PN junction is formed, what happens? Your diffusion current is equal to drift current, and an inbuilt depletion layer is formed between the two junctions. Now, we go for the forward bias and the reverse bias. What happens in the forward bias? In the forward bias, that is the N type in N side, which is negative. Here it is connected to the negative terminal of the battery, and the P side it is connected to the positive terminal of the battery. So here what happens? The applied voltage is applied on the depletion layer, and because of this here we see that this applied voltage, this it reduces the depletion layer, it reduces the barrier potential, because the applied voltage is is opposite to that electric field in the depletion layer, because your applied voltage is it is opposite to the electric field in the depletion layer, and because of that your depletion layer decreases and your barrier potential, that is called the barrier potential, decreases, and here your flow of the electrons is possible, that is the current flows. That means what happens, that is your barrier potential decreases. V naught, that is initially in a PN junction, there is a barrier potential. It is inbuilt there. Let us take V naught. So when in forward bias, since your barrier potential decreases, so it is a V naught minus V. Your barrier potential decreases, and because of this flow of the electron is possible, therefore current flows, and there is conduction of conduction current. Now we go for the reverse bias. In the reverse bias, the N side it is connected to the negative terminal of the battery, and your P side is connected to the positive terminal of the battery. And the applied voltage is in the direction of the electric field. So, electric field of the depletion layer, electric field of the barrier potential. So, your barrier potential increases, that is V naught plus B. So here your barrier potential increases, and at the same time the width of the depletion layer increases. So the conduction of electron is becomes difficult. So in reverse bias, what happens? There is no flow of the current, but there may be some minority charge carrier flow. There may be, but the majority charge carrier, there is no flow of the majority charge carrier. So practically, the current flow, there is no flow of current in the reverse bias. Now, if we increase in reverse bias, if we increase the potential, what happens? A breakdown potential will be, if you go on increasing the potential, that means there will be a breakdown voltage where current will flow, where current will flow, uh, start, current flow will start, and that means your diode is destroyed. So this is about the main fact of your diode. Now this diode, is used as a rectifier. That means it can convert the AC current into DC current. So, as you know, we know that the AC current, it is a sine wave. So, uh, for the upper half of the cycle, the diode act as a forward bias, and the for reverse half it act as for the lower half of the of the curve of the sine curve, it act as a reverse bias. So only it allows the flow of the current on the upper half of the cycle. So here ripples are formed. Now this is half wave rectifier. Now, if we to connect two diodes parallelly, then what happens? For the first diode, the upper half of the cycle is it acts as a forward bias, and for the lower half, it acts as a reverse bias. At the same time, the second diode it acts as a forward bias for the lower half and a reverse bias for the upper half. So we the resultant output will be we get the this is called full wave rectifier, and we get a unidirectional flow of the current. But here there is some problem, that is we see that the current is still fluctuating. To make a steady current, we use a capacitor. And when we use a capacitor, we get a steady current, that is, we get a DC current. So the full wave rectifier, this is called full wave rectifier. By the help of the full wave rectifier, that is, we are going to take two diodes and a capacitor, we can convert the AC current into DC current. So this is all about semiconductors for class 12.